All right, so, we've been diving into some pretty fascinating stuff lately, right? About how we really know what somebody knows when it comes to like education and learning.
Hmm.
And you guys sent over a whole bunch of resources for us on, assessment practices and all
Yeah.
the different ways we try to figure that out.
Right.
And one of the papers that really stood out to me was this one by Brown and Wilson, where they talk about this concept of a missing cornerstone in assessment.
Mm,
So that's kind of what I wanted to focus on in this deep dive with you today, is to really unpack that idea.
absolutely. Yeah, I think that's a really crucial piece of the puzzle, so to speak.
Yeah.
They build on this 2001 National Research Council report that highlighted some key things that need to be in place for assessment systems to really work well.
Okay.
And it's pretty interesting that almost a decade later, this first key element of having a really clear and well-defined model of cognition is still surprisingly missing in a lot of assessments.
Okay, so let's back up for a second and really like define what we mean by this model of cognition
Yeah.
thing, because I think it might sound a little bit jargony to people who aren't, deep in the weeds of educational research.
Right. Yeah.
So like what are we actually talking about here in practical terms?
So the paper describes it as kind of a theory or even just a well-defined set of ideas about how students actually represent knowledge
Okay.
and how they build skills in a particular subject area.
Okay.
So it's really about understanding the underlying processes of learning.
So it's not just can they get the right answer on a multiple choice test.
Exactly right. Yeah, it's going deeper than that surface level stuff.
Yeah. Okay. So for you, like if you're thinking about any assessment that you come across in your work,
Yeah.
you're always kind of asking, is there a clear picture here of how someone's actually supposed to learn this thing?
Right.
Or are we just measuring whether they happen to know the answer at this moment in time?
Exactly.
Yeah.
Yeah, and it's really about getting inside the student's head,
Mm.
so to speak, and understanding what their thinking processes are like.
So it's almost like the difference between knowing that someone can drive a car
Uh-huh.
versus actually knowing how a car engine works.
Yeah, that's a great analogy.
Right. Like one is kind of just observable behavior, and the other one is a much deeper understanding of the underlying mechanisms.
Precisely.
Yeah.
Yeah, and I think a good way to think about it is kind of like a blueprint
Okay.
of understanding, how does a student go from knowing absolutely nothing about a concept
Okay.
to having a deep and usable knowledge of it?
Gotcha.
And what are the different stages they go through? What
Okay.
are the different ways of thinking?
Yeah. So what are the different like mental models or schemas that they're constructing in their minds?
Exactly. Yeah. And that's the kind of thing that a model of cognition aims to capture.
Okay.
And I think Brown and Wilson make a really strong argument that without this explicit model, our assessments can be really misleading.
Okay.
They might not actually be measuring what we think they're measuring.
Right. Yeah, they might be measuring something else entirely.
Exactly.
And we might be drawing the wrong conclusions about what students know and can do.
Absolutely.
Okay, so this is where the idea of construct modeling comes in, right?
Right. Yeah.
Because this is presented as a way to actually design assessments where that missing cornerstone, that model of cognition, is kind of baked in from the beginning.
Yes. Exactly. And it becomes the central part of the entire process.
Okay, so for everyone listening today, our mission is to really understand why this model of cognition is so crucial and how using this construct modeling approach can give us a much better picture of what's happening in a learner's mind.
Absolutely.
So one of the things that I thought was really interesting in the paper is they talk about assessment as kind of a cycle
Mhm.
rather than just a one-time event, like you give a test and you get a score and that's it.
Right. Yeah.
So can you kind of walk us through those stages of the assessment cycle and how these cornerstones fit in?
Sure. So the paper outlines this four-step cycle.
Okay.
And the first one is observing.
Okay.
And that's really about, designing tasks or, questions
Hmm.
or activities that give students opportunities to show what they know and what they can do.
Okay, so like actually eliciting some kind of performance from them.
Exactly. Yeah, give
Yeah.
them a chance to perform and demonstrate their knowledge and skills.
Okay, and then what's the next stage?
So the second step is scoring.
Okay.
And this is where we categorize and assign some kind of value to their performance on those tasks.
Okay, so this is where we start to say like, okay, this response is better than this response, or this one's correct and this one's incorrect.
Exactly. Yeah, you're making judgments about the quality of their work.
Okay.
And then the third step is summarizing.
Okay.
And this is where we use a measurement model,
Mm-hmm.
which is basically a statistical framework
Right.
to help us make sense of the patterns in all those scores that we've collected.
Okay, so this is where we start to look for trends and try to quantify the data in some way.
Exactly. Yeah, we're trying to find the signal in the noise.
Gotcha. And then what's the final stage?
So the final stage is interpretation.
Okay.
And this is where that model of cognition becomes absolutely critical
Okay.
because it helps us to understand what those summary scores that we've generated actually tell us about a student's underlying understanding.
Okay, so it's like we've gathered all this data,
Yeah.
we've crunched the numbers,
Mm-hmm.
but now we need to actually make meaning of it. And that's where the model of cognition comes in.
Precisely.
Right.
Yeah, and I think this highlights how important that model of cognition is.
Mm-hmm.
Because without it, we're just kind of left with a bunch of numbers that don't really tell us much.
Right, yeah, it's like having a map without a legend.
Exactly.
You can see all the lines and the shapes, but you don't know what they represent.
Exactly.
Yeah.
Yeah, you need that key to unlock the meaning.
Okay, so to kind of recap, each of these stages in the assessment cycle relies on a specific tool, one of these cornerstones that we keep talking about.
Right.
So we have tasks for observing.
Uh-huh.
We have scoring guides for the scoring stage.
Yeah.
We have a measurement model for summarizing the data.
Mm-hmm.
And then we have the model of cognition for guiding our interpretation.
Exactly. Yeah, it's like a recipe with 4 essential ingredients.
Yeah.
You can't leave one out or the whole thing falls apart.
Right. It's not enough to just have like really good test questions.
Yeah.
We also need a clear idea of how someone learns the material being tested
Precisely.
in order to interpret their answers in a meaningful way.
Absolutely. Yeah, it's
Yeah.
all interconnected.
Okay, so the paper contrasts this ideal cyclical approach with how assessments are often developed in the real world, which they say is often much more flawed.
Yeah.
So can you describe what that typical process looks like and where it falls short according to Brown and Wilson?
Sure. So the more common approach, which they depict in Figure 4 in the paper,
Right.
tends to be much more linear.
Okay.
It's kind of like a step-by-step assembly line process.
Mm-hmm.
So it usually starts with content experts getting together, and they create the assessment items, like the questions or the tasks that students will have to do.
Okay.
And then once they have those items, they develop scoring guides or rubrics to evaluate the responses to those specific items.
Okay, so they're kind of working backwards from the questions rather than starting with the bigger picture of what they're trying to assess.
Exactly. Yeah, they're very focused on the individual pieces rather than the whole puzzle.
Gotcha.
And then after that, they usually pilot test the items with a group of students.
Okay.
And then they use various statistical methods to analyze how the items performed.
Okay.
Like, did students tend to answer them correctly or incorrectly?
Mm-hmm.
Were there any items that were confusing or ambiguous?
Right. And so if those statistical results look good, they're like, okay, we're done here.
Pretty much.
Yeah.
Yeah, maybe they'll do a little bit of tweaking or refining if necessary.
Mm-hmm.
But the main focus is on the statistical properties of the items.
Okay, so it sounds like a very data-driven approach.
It is. Yeah, and there's definitely a place for that. But the problem is that this linear development process often marginalizes or even completely ignores the model of cognition.
Okay, so they're so focused on getting the items right and making sure they have good statistical properties that they forget to ask the bigger question of, like, what does this actually tell us about how students are learning?
Exactly, yeah. They're missing that crucial piece of the puzzle.
Okay, and the paper argues that this is a really big problem because it can lead to assessments that are technically sound, but ultimately not very meaningful or useful.
Right, yeah. They might be reliable in the sense that they produce consistent scores,
Mm-hmm.
but they might not actually be valid.
Okay, and just to remind everybody, what do we mean by validity in this context?
So validity is all about whether an assessment is actually measuring what it's supposed to be measuring.
Okay.
So it's not just about getting consistent results, it's about making sure those results are actually meaningful and relevant to the thing we're interested in.
Okay, so an assessment could be very reliable. Like, you give it to the same person multiple times and they get the same score, but it could still be completely invalid if it's not actually measuring the construct that we care about.
Exactly. Yeah, that's why the model of cognition is so important, because it helps us to define that construct in a clear and precise way.
Okay, so it's like the North Star that guides the whole assessment process.
Exactly.
Yeah.
It's what keeps us on track and makes sure we're actually measuring what matters.
Okay, so let's talk more about this missing cornerstone, the model of cognition itself.
Sure.
We mentioned earlier the National Research Council's definition, which is that it's basically a theory about how students represent knowledge and develop competence in a subject.
Hmm.
But why is its absence such a critical issue, according to Ms. Levy, who's quoted quite a bit in the paper?
So Ms. Levy argues that a lot of what we consider to be like standard test theory,
Okay.
like the statistical frameworks that we commonly use to analyze assessment data,
Mm-hmm.
like classical test theory or item response theory,
Yeah.
all these different approaches,
Right.
he says that they're really rooted in behavioral psychology.
Okay.
And so they're really good at like summarizing how groups of students tend to respond to certain stimuli.
Okay.
And they're really good at, you know, determining overall levels of proficiency
Okay.
and for like making comparisons between students.
Right, like this student is at the 90th percentile and this student is at the 50th percentile.
Exactly.
Yeah.
But as Ms. Levy puts it, conjectures about the nature of this proficiency or how it develops falls largely outside the mental measurement paradigm's universe of discourse.
Wow, that's a mouthful.
Yeah.
Okay, so can you unpack that for us a little bit?
Basically, what he's saying is that these theories can tell us how much proficiency somebody seems to have,
Okay.
but they don't really tell us anything about what that proficiency looks like
Okay.
in terms of actual understanding,
Gotcha.
or like the different ways that somebody might be thinking about a subject, or how that understanding typically develops over time.
Okay, so it's like they can give you a number,
Uh,
but they can't really tell you the story behind that number.
exactly. Yeah, they're missing the narrative.
Okay.
And that's a really big problem because it means that we might be making decisions based on incomplete information.
Right.
Yeah.
Yeah, we might be thinking that a student understands something when they really don't.
Exactly. Yeah, or we might be misinterpreting their strengths and weaknesses.
Okay, so let's talk about the benefits of actually having a well-defined model of cognition.
Sure.
Like, how does that actually help us in the educational process?
So the paper highlights 3 key areas where it can make a really big difference.
Okay.
And those are curriculum development, instruction, and evaluation.
Okay. So basically all the major components of education.
Exactly. Yeah, it touches on everything.
Okay, so let's start with curriculum development.
Sure.
How does having a model of cognition help us design better curricula?
So if we have a really clear understanding of how students typically learn a particular subject, then we can create more effective and logical learning sequences. Right? We can align the content and the way we present it with how students naturally build understanding.
So it's not just about teaching the facts in a random order.
Right.
It's about understanding the underlying cognitive processes
Exactly.
and then structuring the curriculum in a way that supports those processes.
Precisely. Yeah, and that can make a huge difference in how well students learn.
Okay, so what about instruction?
So for instruction, having a model of cognition can really empower teachers
Okay.
because it allows them to interpret assessment results in a much more insightful way.
Okay.
So instead of just seeing that a student got a question wrong, they can start to understand why they might have gotten it wrong
Okay.
based on their level of understanding as defined by the model of cognition.
So it's not just about identifying the gaps in their knowledge.
Right.
It's about understanding the reasons behind those gaps.
Exactly. Yeah, and that allows teachers to tailor their teaching much more effectively.
So they can provide more targeted support.
Exactly.
Yeah.
Yeah, they can meet students where they are.
Okay. And then what about evaluation?
So for evaluation, having a model of cognition means that we can aim to assess more than just basic recall of facts.
Okay.
We can start to design assessments that really target higher order thinking skills, like problem solving and critical thinking and creativity.
Right. All those 21st century skills that everyone keeps talking about.
Exactly, yeah. And those are the skills that are going to be really important for students in the future.
Right. Yeah. They need to be able to think for themselves and solve problems.
Absolutely.
Not just regurgitate facts.
Exactly.
Okay. So if I'm understanding this correctly, having a good model of cognition can basically help us to design better learning experiences across the board.
That's the idea.
Yeah.
It's about creating a more holistic and effective approach to education.
Okay, so let's talk about how we actually do this.
Sure.
How do we actually put this into practice?
So that's where construct modeling comes in,
Oh.
which is the approach that Brown and Wilson are advocating for in the paper.
Okay, so remind us again, what is construct modeling?
So construct modeling is an approach to assessment where the model of cognition is right at the center of the entire design and development process.
Okay, so it's not just an afterthought.
Yeah.
It's not something that we tack on at the end.
Exactly. Yeah, it's the foundation that everything else is built on.
Okay, so how does it actually work?
So in construct modeling, a student's proficiency in a particular area is viewed as what's called a continuous latent variable.
Okay, and before you go any further, can you just explain what a latent variable is?
Sure. So a latent variable is basically something that we can't directly observe or measure.
Okay.
So like intelligence or motivation, or in this case, a student's understanding of a particular concept.
Okay, so we can't just like look inside their brain and see how much they understand.
Right, exactly.
We have to infer it from their behavior.
Exactly, yeah, and that's where the assessment comes in. Because it gives us a way to observe their behavior and then use that to make inferences about their underlying understanding.
Okay, so in construct modeling, we're assuming that a student's understanding of a concept exists on a continuum.
Exactly.
Yeah.
Yeah, it's not just a yes or no question.
Right.
It's a spectrum
Okay.
ranging from like initial, maybe intuitive understanding all the way to highly developed expertise.
So instead of just saying like this student knows this concept or they don't know it, we're saying like, okay, they're at this level of understanding on this continuum.
Precisely.
Yeah.
And that gives us a much more nuanced and informative picture of their learning.
Okay, and the paper also talks about how this approach aligns with the idea of learning progressions.
Yes, exactly.
Which I know is a big topic in education these days.
Yeah.
So can you explain what learning progressions are and how they connect to construct modeling?
Sure. So a learning progression is basically a map of how students typically develop understanding in a particular domain. So it outlines the different stages or levels of understanding that students go through
Okay.
as they move from novice to expert.
Okay, so it's kind of like a roadmap for learning.
Exactly.
Yeah.
And construct modeling is very much aligned with that idea
Okay.
because it recognizes that learning is a continuous process and that students don't just suddenly jump from not knowing something to knowing it. Right? They gradually develop their understanding over time.
Okay, and so the key with construct modeling is that all four of those cornerstones that we talked about earlier, the tasks, the scoring, guides the measurement model, and the model of cognition. They're all intentionally designed and evaluated to make sure that they're consistent with this underlying model of cognition.
Exactly. Yeah, it's all about coherence.
Okay.
Making sure that all the pieces fit together and that they're all working towards the same goal.
And that goal is to get a really accurate and meaningful picture of student learning.
Precisely.
Okay, so the paper gives a really great example of this in action. With this study that focused on students' understanding of dynamic equilibrium in chemistry,
Yeah.
can you tell us about that study and how they used the principles of construct modeling?
Sure. So this was the multidimensional measure of conceptual complexity study, or MMCC for short.
Okay.
And it was conducted with undergraduate chemistry students.
Okay.
And one of the key elements of their approach was developing what they call construct maps.
Okay.
And you can see an example of one of these maps in Figure 6 in the paper. And basically what a construct map is, it's a visual representation,
Okay.
almost like a learning roadmap
Okay.
that describes the different levels of conceptual understanding for dynamic equilibrium.
Okay, so it's kind of like a flow chart
Yeah, kind of.
where you start at the bottom with the most basic understanding, and then you work your way up to the more sophisticated levels of understanding.
Exactly.
Yeah.
It outlines the different pathways that students might take as they develop their understanding.
Okay, and one of the things that the paper emphasizes is that content experts alone might not be the best people to create these construct maps.
Right. Yeah, that's a really important point.
Okay, why is that?
So content experts obviously have deep and extensive knowledge of the subject matter,
Sure.
but they can sometimes develop what's called the expert blind spot.
Okay, I've heard of that.
Yeah, so basically what that means is that because their understanding is so advanced and automatic, they might not be aware of the specific challenges that novice learners face.
Right, yeah, they might forget what it's like to not know something.
Exactly.
Yeah.
And so they might create a construct map that's too complex or too abstract for students who are just starting to learn the concept.
Okay, so it's important to involve other people in the process of creating these construct maps.
Absolutely.
Yeah.
Yeah, so you want to have people like experienced teachers
Yeah.
who work with students on a daily basis and really understand how they learn. And you also want to have educational psychologists who understand the cognitive processes involved in learning.
Yeah.
And you might even want to have measurement experts who can help to ensure that the construct map is useful for assessment purposes.
Okay, so it's a really collaborative process.
It is, yeah. It's
Huh.
about bringing together different perspectives to create the best possible map of student understanding.
Okay, so once you have this detailed map of understanding, how do you actually go about designing the assessment questions or tasks?
So that's where item design comes in,
Okay.
which is basically a framework for creating tasks that are specifically designed to elicit responses that will reveal a student's level of proficiency,
Okay.
as described in the construct map.
Okay, so the tasks are intentionally designed to target those different levels of understanding.
Exactly. Yeah, and there are different ways to do this.
Okay.
So in the MMCC study, they used a lot of open-ended questions, which were carefully crafted to encourage students to really explain their thinking in their own words.
Okay.
And that allowed their responses to kind of naturally fall across those different levels of the construct map.
Okay, so it's not just about getting the right answer.
Right.
It's about understanding how they got to that answer.
Exactly. Yeah, it's about the reasoning process.
Okay, but the paper also mentions that you can use other item formats as well,
Yeah, absolutely.
like multiple choice questions.
Yes.
So how do you do construct modeling with multiple choice questions?
So the key is to design the distractors in a way that reflects those different levels of understanding.
Okay.
So for example, if you have a question about dynamic equilibrium, you might have one distractor that reflects a very basic understanding of the concept,
Okay.
and then another distractor that reflects a slightly more sophisticated understanding, and so on.
Okay, so the distractors are kind of like signposts that point to those different levels of the construct map.
Exactly.
Yeah.
Yeah. And that allows you to get a much richer and more nuanced picture of student understanding, even from a multiple choice question.
Okay, so we've got the construct map. We've got the tasks that are designed to elicit those different levels of understanding. But then how do we actually go about scoring those responses, especially for the open-ended questions?
Right. Yeah, that's a really important part of the process. So this is where outcome spaces come in.
Okay.
And basically what an outcome space is a detailed description of the different kinds of student responses that you might expect to see for each assessment task.
Okay.
And crucially, these descriptions are directly linked back to those different levels of understanding that are outlined in the construct map.
Okay, so you're essentially creating a rubric for each question.
Yeah, that's a good way to think about it.
Where each point on the rubric corresponds to a specific level of understanding.
Exactly. Yeah. And so when you're scoring a student's response, you're not just looking for whether they got the right answer or not. You're looking for evidence of their level of understanding, as defined by the construct map.
Okay, so it's a much more qualitative approach to scoring.
It is, yeah. It's about really understanding the student's thinking.
Okay, so we've talked about the tasks. We've talked about the scoring.
Yeah.
Now, what about the measurement model?
Right.
What kind of statistical framework did they use in this particular study?
So in the MMCC study, they used the RASH model family.
Okay.
Specifically Master's partial credit model.
Okay, and I know that there are a lot of different statistical models out there.
There are, yeah.
So why did they choose the RASH model?
So the authors argue that RASH models are particularly well suited for this construct mapping approach.
Okay.
Because they allow you to estimate both a person's level of proficiency and the difficulty of different steps within the assessment items.
Okay.
On a shared single scale.
Okay, that sounds useful.
Yeah. And what's particularly valuable is that this scale can be directly interpreted in relation to those levels that are defined in the construct map.
Oh, okay. So you're essentially putting the student's understanding and the difficulty of the tasks on the same measuring stick.
Exactly.
Yeah.
Yeah, and that helps us to see if a student is struggling because they don't understand the concept or because the question is just really hard.
Gotcha.
According to our model of how that understanding develops.
Okay, so it's not just about looking at raw scores. It's
Right.
about understanding what those scores actually mean in the context of the construct map.
Precisely. Yeah, it's all about context.
Okay, and this brings us to the right map,
Yeah.
which sounds like a really powerful visual tool.
It is, yeah. It's one of the really cool things about the RASH model.
Okay, so what does a right map actually show us?
So a right map, like the one in Figure 8 in the paper, basically plots two distributions on the same scale.
Okay.
And that scale is typically represented in logits.
Okay, and can you just remind us what a logit is?
Sure. So a logit is just a unit of measurement that's used in RASH analysis.
Okay.
And it's basically a way of transforming raw scores into a scale that's more interpretable and useful for comparing students and items.
Okay, so on the right map, we've got these two distributions. What are they?
So on one side, usually at the left-hand side, you see the distribution of estimated proficiency levels for all the students who took the assessment.
Okay.
And then on the other side, you see the distribution of the difficulty levels for the different steps within the assessment items.
Okay, and you mentioned something called Cornerstone thresholds.
Yeah, so those are represented by those little horizontal lines that you see on the right map.
Okay.
And basically what a Thurstonian threshold is, it's the point on the proficiency scale where a student has a 50-50 chance of getting a particular step on an item correct.
Okay, so it's like the tipping point
Exactly.
where they're equally likely to get it right or wrong.
Mm-hmm. And those thresholds are directly linked to those different levels of understanding that are defined in the construct map.
Okay, so the right map is not just showing us raw scores.
Right.
It's showing us those scores in relation to the construct map.
Exactly. Yeah, it's giving us a much richer and more meaningful picture of student understanding.
Okay, so looking at the example right map from the MMCC study, what kind of specific insights did they gain about these undergraduate chemistry students' understanding of dynamic equilibrium?
So the right map revealed some really interesting patterns.
Okay.
For example, it showed that while most students were able to provide basic causal explanations for dynamic equilibrium,
Okay.
they generally struggled to provide more in-depth justifications for those explanations.
Okay.
And even the students who demonstrated the highest levels of overall proficiency
Mm-hmm.
still encountered difficulties with the more complex system-related explanations,
Okay.
except for the item that was specifically about water evaporation.
Interesting.
And the researchers hypothesized that this might be because water evaporation is a system that's very familiar to students.
Okay.
They've been learning about it since elementary school.
Right.
So they have a lot more experience with it.
Okay, so the right map is really giving us a much more fine-grained picture of student understanding.
It is, yeah.
Yeah.
It is allowing us to see not just an overall score, but also specific areas of strength and weakness in relation to those defined levels of understanding in the construct map.
Okay. And the paper also talks about how this construct modeling approach can lead to improvements in the validity of assessments.
Yes, absolutely.
So how does that work?
So in traditional assessment development, the validity of an assessment is often examined kind of towards the end of the process.
Okay.
And it primarily focuses on the relationship between the statistical properties of the assessment, which is like the measurement model
Okay.
and the actual tasks themselves.
Okay.
But with construct modeling, the emphasis is on achieving coherence and alignment across all four cornerstones. The tasks, the scoring, guides the measurement model, and most importantly, the underlying model of cognition.
Okay.
And so if the results that we get from our statistical analysis don't align with the predictions or the structure of our cognitive model,
Okay.
that raises a red flag.
Okay.
It tells us that there might be a problem either with the assessment itself or with our understanding of how learning in that domain actually unfolds.
Okay, so it's like a reality check.
Exactly.
You're constantly comparing your data back to your model of cognition to make sure that they're telling the same story.
Precisely.
And that's exactly what happened in the MMCC study, right?
It is, yeah.
They found some inconsistencies in their data that led them to refine their initial model of cognition.
Exactly, yeah. So they initially thought that students' understanding of dynamic equilibrium could be represented on a single unidimensional scale.
Okay.
But then when they actually analyzed the data, they found that about 20% of the students,
Okay.
their patterns of responses didn't quite fit that model.
Interesting.
And so they had to go back and revise their initial thinking.
Okay.
And they ended up realizing that conceptual composition,
Which is what?
which is the ability to identify the different components of a system,
Okay.
and conceptual justification,
Okay.